Hello, my name is Alan Kelly. Welcome to my video blog, Testing 1 2. Let me start by asking you a couple of questions. When you are doing work, who in your organization does the post-project or post-release, post-deployment evaluation? Who in your organization goes to the customers and users that you've created a product for and talks to them about how they relate to your new software, your updated software? Who goes and talks to your users about what they can now do that they couldn't do before and how much they like it? Who looks at whether the cost savings are envisaged are realized? Who looks at whether the sales increases that were envisaged are realized? Who goes and looks at what side effects your new software has that you didn't expect? Who does that? Let me suggest that while we all agree it's a good idea we do these kind of post-release evaluations, and everybody says they're important, actually very few teams do. Let me also suggest that going forward in our agile world, post-release evaluations are going to be even more important. My second question for you: why do cars have brakes? Stop and think about that for a moment. Most people, when you pose that question, and I must say I stole this question from my good friends Kevlin Henning and John Jagger. Most people, when asked this question, will say, well, so you can slow down, so you don't hit anything. But if you think more deeply, you realize there's another answer behind that. And let me tell you, I've driven a car with no brakes, or rather, I've driven a car which had no foot brake. Back when I was young in the first few years of driving, I had a car and the foot brake failed. I could still stop the car using the handbrake and perhaps using the gears, the shift stick, but it was more difficult. And of course, when a car is broken like that, you need to get it repaired. So I needed to drive it to a mechanic, a garage, to get it repaired. And between where the car was and where the garage I was going to there was a hill. So how do you think I drove? Well, I'll tell you, I drove very slowly. And whenever I reached a point like some traffic lights or a junction, I slowed down a long way in advance. I could stop the car by using a combination of the gears and the handbrake again, but I didn't know quite how long it was going to take, and I was very scared doing this. I drove very slowly. The real reason, the deeper reason why cars have brakes is so that you can go fast. If a car did not have a brake... Now remember when you learned to drive? How you were taught that you should always be able to drive within your stopping distance? If your car didn't have a brake, your stopping distance is much greater. Therefore you must drive more slowly. Cars have brakes so you can go fast. And the same is true in software development. We have tests in software development so you can go faster. The old model still works, it isn't that different, we'll talk about Agile in a minute. But traditionally, development, coding work begins with an analyst somewhere, a product manager, a product owner, a business analyst, a systems analyst, somebody analytical saying, this is what we need. And that is communicated to a coder who goes away and codes it up. And when the coder thinks they are done, the coder passes it to a tester. And in all our textbooks, everything's hunky-dory then, and we then move on to give it to our customers or users. In reality, anyone who's worked in profession knows the tester sends it back. They found a problem, and it goes back, and the tester sends it back. And we test, fix a number of times, and we iterate between these two states. And unfortunately, this is the point, which isn't in any of the traditional models, where we lose our schedules. All our predictability is blown, because you don't know at what point the tester is going to say, yeah, that's good to go. Or at what point the tester is going to say, no way is this going out. You can't have a predictable schedule while you've got this almost random loop. Sooner or later, we get something that passes the tests, or more likely we decide they aren't that important, and we can push it out into the ether, into what we used to think of as the cloud, and now really is the cloud. And once it's there, once it's been shipped on a CD or uploaded somewhere, then our customers can use it. Yes! And that's when we should be doing our post-project, post-release evaluations. So think about it like this. We've got Type 1 testing upstream before it gets to the customer. And Type 1 testing, which is normally performed by a professional tester, is does this software work? Does it do what we intended it to do? Or does it crash horribly? Does it introduce any new faults? Heaven forbid, does it introduce faults that we've seen before and we thought we got rid of? Regression testing. That's upstream testing before it gets to a customer. But we also have type 2 testing downstream when it's with customers, when it's with the users. And here we should be saying, does it meet the need we originally thought we had? Does it sell in the market? Is it competitive in the market? Does it earn our investment back? The money we've paid building this, adding this feature, building this product. Does the benefit, the revenue generated, the cost saved, the improved functionality, improved quality, does it justify the money spent? That's type 2 testing. And that's what we just call post-project review and evaluation. And when we move to the agile world, things really aren't that different. The analyst, the coder, and the tester are a bit closer together. Yes, and they work a bit more closely, and hopefully they talk rather than write. And we push it out into the actual cloud, AWS, and it gets to customers. But we still have these two types of testing. We still have upstream type 1 testing. Does it work? Does it introduce any new problems? And type 2 downstream testing. Does it meet the need? Does it sell to the customers? The aim of testing is, the type 1 testing specifically, is not to ensure the product is free of defects, because that is impossible. Even if you can show that the new code introduced by your team is free of defects, what about the compiler and interpreter that runs that code? Is that free of defects? Has that introduced an error? What about the third-party libraries and open source you use? What about the platform you run on, the app server, the web server, the operating system? And if all of those are bug defect-free, what about the hardware, the CPU, and the microcode in the CPUs? It's impossible to verify that software is free of defects. All we can do is ensure that it is free of enough defects to push it out there, to put it in the hands of customers. So the aim of testing is knowing when to stop, knowing when you can put it into the hands of customers and you can gain external feedback. External feedback is the important thing. I write books. I've written several books. When I'm early on, when I'm writing them, I send them out to reviewers, and I want the reviewers to tell me, do the ideas make sense? Do I explain myself clearly? Would they spend their money on a book like this? Things like that, things about the content. Overwhelmingly, the feedback I get is about my spelling, my grammar, my punctuation. Hey, I know I'm bad at all those things. I'm dyslexic, and I pay a professional copy editor at some point to fix all those things. When I send early editions of my book out, what I really want is feedback on my ideas and my explanations. Overwhelmingly, what I get back is feedback on my spelling, grammar, and punctuation. It's type 1 and type 2 testing again. I want type 2. I get type 1. The thing is, if your type 1 test, if your initial quality is poor, your type 1 is weak, then getting type 2 is far more difficult. You just get bug reports. I imagine developers working like this. Developers are sitting there coding away, and they're executing a mental loop in their head. Do development. And while the tests aren't passing, they do some more development. And if the acceptance tests don't pass, then they change the code to pass the test, pass the acceptance tests. And if the acceptance tests do test, are there any significant defects? And they go and fix it. And they keep looping through this until all the tests pass. We're looking for testing to stop development. We test until we can pass it. Type 1 testing has no value in and of itself. Type 1 only exists to make type 2 testing meaningful. Type 1 is about getting enough defects out of the system, enough spelling mistakes and grammar mistakes in my books out of the system, so people can concentrate on what the software does, what is the message in my books. When you have poor quality, that's a lot of bugs in software, it obscures type 2 testing. Type 2 testing, on the other hand, is, does it solve a customer problem? Does the customer have a new problem we can help with? So you solve that problem and now you see the next problem. Does the cost of developing the solution justify the value, both in what we've just done and the potential problem we could address next? Is it worth spending more money here? Type 2 testing informs decisions on what to do next. It informs portfolio and governance. Type 2 testing, a focus on value, allows us to move away from traditional project success criteria of schedule, budget and features. The fact is, schedule, budgets and features, there's nothing about value in there. There's nothing in there about have we solved the customer problem. Just have we spent all the money in the time we said we'd do it, and have we implemented the features we thought would be necessary. What we want to focus on is actual outcomes, deliverables and value, and that is type 2 testing, and that happens downstream when we look at what customers and users do with it. Testing is no longer about what was done. Testing is about what will be done, and we find out what we need to do next by looking at how customers are using what we've given them. The tests we set, the type 1 tests, specify what needs to be done. This is what in Agile we call test first or test driven. We write the tests, the acceptance tests, the tests to pass type 1 testing, the upstream testing, before we write the code. And when you do this, you remove ambiguities and interpretation from the specification document. It's not English words anymore, it's executable tests. And working test first and creating specifications without ambiguity allows you to do less engineering, do less of the over engineering you do, and just do generally less. And test first, test driven, testing in advance does something else. When we automate those tests we set early on, acceptance tests with the testers and unit tests with the developers, these remain for posterity, they stay with us, and these form our regression tests in future. So regression tests are free. And free regression tests, no time and money spent creating regression test suites, and reducing the overall engineering means that we are faster to market, and faster to market is good in its own right, and faster to market increases our value delivered to customers and users, and faster to market also means that we get feedback from our customers and our users on market sooner, and that informs our next work. And that is a game changer. One more change for you, one more change. When we start to pull tests forward, when we pull tests further upstream, and when we take evaluation post-deployment review more seriously, you start to find that your tester and your analyst swap places. The tester comes to the fore in the process and does a lot of work before any code is written, and the analyst, product owner, product manager, kind of moves downstream, and they are looking at what customers do with our software. So there's a change in roles, and that really is a change to our general way of working. Thank you very much for listening. I hope you found that useful. Type 1 testing, move it forward, reduce it. That allows Type 2 testing to expand. My name's Alan Kelly. My contact details on the screen. Some of my books are there. I have a newsletter with my thoughts, ideas, and workshops and offers in there. I run some workshops from time to time. Subscribe to the newsletter, you'll be the first to find out about them. And if you subscribe, you'll get an e-book for free. If you have any questions, please email me on the address there. Thank you very much. Goodbye.